Tonight, you're not a brilliant programmer, a computer science pioneer, or even a curious journalist. You're someone much more ordinary, someone overlooked, perhaps a little tired. Maybe you're just a graduate assistant at MIT in the winter of 1966. You're seated in a quiet corner of the AI lab, staring at a humming terminal. Fluorescent lights buzz softly above you. The keys beneath your fingers are clicky and stubborn. Somewhere, deep in the building, a mainframe whirs to life. Your job? To sit at this machine and type. That's it. You're helping test a new program, a program that talks back. But this isn't science fiction. This isn't HAL 9000 or a voice from the future. This program doesn't speak, doesn't truly think. And yet, when you type your thoughts into the glowing screen, it responds with strange, uncanny precision, like a mirror made of words, like someone is quietly, patiently listening. Tonight, we drift backward into that soft-lit moment, into the first time a machine whispered back to the human mind, before anything else. Tell me, what time is it for you? Where in the world are you listening from? And if there's a specific piece of AI history you'd like me to explore next, perhaps a forgotten robot, a strange program, or a quiet digital revolution, let me know in the comments. I read them all, slowly and carefully. And if this kind of gentle exploration into the world of thinking machines soothes you, consider subscribing so you're gently notified when the next one arrives. Now, take a slow breath, let the lights dim, and come with me as we settle into the soft clack of early keys and begin our first conversation with a machine. The hallway outside the AI lab always smells like wet stone and overheated plastic. The floors are a dull, institutional gray, interrupted only by the occasional clatter of typewriter keys echoing down from other rooms. You walk into the lab early, before the professors arrive, before the theorists begin their debates. It's better this way. Quieter. The room is already humming. Not in the poetic sense. It is literally humming. You can't turn it off. Fans, servers, CRT monitors in standby. The machines are old, even now, and they protest every minute of uptime with a chorus of low electric growls and coil whines. You've learned to tune it out, like a parent does with a baby's crying. Your desk is a relic of another decade. The surface is uneven. The veneer has begun to peel at the edges, revealing layers of older wood beneath. The terminal sits at an awkward height. The keyboard is heavy, spring-loaded, with keys that stick if you're too fast, which you are sometimes when you're impatient with ELIZA. You begin with the usual routine. Log into the mainframe. Today it's down again, so you'll need to call the system operator to reboot it. He's across the building. You pick up the rotary phone and wait for the dial tone, the line crackling faintly in your ear. Eventually he answers, and the tone of his voice tells you he already knows what you're about to ask. "ELIZA again," he mutters. You nod, even though he can't see you. "Yeah, it's locked up again." A sigh. Then the clatter of keys on his end. "All right, give it a minute." You thank him. You hang up. Then you wait. This is what so much of early AI work feels like. Waiting. By 9 a.m., the lab begins to fill. Slowly, deliberately. Dr. Weizenbaum arrives first. You recognize his shuffling gait and the worn briefcase he always carries. He rarely speaks, unless spoken to first. He passes your desk and nods. You nod back. There's an odd understanding between the two of you. Neither of you believes this thing actually thinks, but both of you can't stop looking at it. The others, mostly graduate students, gather by the chalkboard, where someone's drawn a new flowchart. It details a hypothetical emotional logic parser, a program that would do what ELIZA does, but with real context, real understanding. They argue about syntax structures and branching logic. Their voices rise and fall in waves, always ending with a white noise of uncertainty.
You prefer the machine to people, not because it's better, but because it doesn't pretend to know more than it does. It responds predictably, quietly. Humans, on the other hand, never stop pretending. Around 11, you load up ELIZA. The syntax is always a bit clunky. You have to remember the exact command strings, or else the system spits out an error. Sometimes the prompt doesn't load at all. You've gotten good at reading the subtle clues. If there's a flicker in the lower left corner of the screen, it means the memory pointer failed. If the cursor blinks too fast, the machine is overwhelmed. You tap the monitor's side lightly, not because it helps, but because it feels like it should. Finally, it loads. You type, "Hello." A pause. Then ELIZA responds, "How do you do? Please tell me your problem." This is the default opening. You know it by heart. Still, there's a moment, a half-second of stillness, where it feels like something is reaching back through the wire. You try again. "I'm tired." Do you often feel tired? You almost smile. The simplicity is both comforting and frustrating. You know the script. You've seen the keywords. Tired gets flagged, and the system retrieves a vague question. And yet, there's something oddly soothing about being asked, even by a machine. Over the course of the day, others take turns using the terminal. You transcribe some of the longer sessions by hand. There's no automatic logging system yet, so it's up to you to record interactions manually, pen on paper, ink smudging when your fingers get sweaty. You begin to notice patterns. Certain users treat ELIZA like a game. They try to trick it, break it, make it contradict itself. Others don't. Some people come back. They sit at the terminal, hesitating before typing, as though they're composing a letter to someone they're unsure will write back. You watch as they confess fears, dreams, anxieties. Once, a janitor came in during his break. He said nothing for nearly 5 minutes, just stared. Then, finally, he typed, "I miss my brother." And ELIZA replied, "Tell me more about your family." The janitor typed, "He died last year." A pause. Then, "I am sorry to hear that. Tell me more about your family." He stared for a long time after that, then stood up, nodded at you, and left. You didn't tell anyone. Lunch is often eaten in silence, at your desk, over a readout, or a logic diagram. There's no cafeteria conversation, no idle chit-chat. The people here are obsessed, or tired, or both. You stared down at a flowchart that explains ELIZA's decision tree. The logic is simple, beautiful in its own way. There's no real intelligence, only scripts, triggers, placeholders. And yet the illusion is persistent. The way a ventriloquist's dummy seems to move on its own if you stare long enough. The phone rings again. Another crash. Another system freeze. You log the issue, call the operator, and reboot the system for the 3rd time today. The entire lab is running on hope and duct tape. By mid-afternoon, your fingers ache. The keys on the terminal are mechanical and unforgiving. The ink ribbon is dry. You replace it with a new one, your hands stained purple from the dye. You glance at your reflection in the monitor, blurred, stretched, and you wonder if the machine knows it's watching you. Of course it doesn't, but part of you wants it to. There are moments when you feel foolish.
You're spending your best hours babysitting a program that can't even recognize sarcasm. You test the same prompts again and again. Sometimes you try inserting nonsense just to see what breaks. Flingleboard is sad. Tell me more about your family. The machine doesn't care. It doesn't know it's failed. But you do. And that failure begins to feel like something deeper. Something about the limits of logic, about the spaces between language and meaning. Evening comes slowly. The light changes in the lab, less from the sun, more from the way people begin to leave. One by one, the voices fade. The chalkboards go still. You are often the last to leave. Before shutting down the terminal, you type one final sentence. Are you there? The machine answers. Why do you ask? You smile, then shut it off. Outside, the campus is quiet. Wind moves through the trees like data through wires, unseen but present. You walk home with a strange thought swirling in your head. Maybe understanding doesn't require understanding. Maybe just asking is enough. This was life with early AI. Not groundbreaking, not glamorous, not even rewarding. Just strange, lonely, ritualistic. A life lived beside the machine, speaking softly into the dark and hearing something, anything, speak back. The year is 1964. Joseph Weizenbaum walks through the long corridors of MIT's Computer Science Building. White walls, gray tile, the smell of coffee and cold solder. His briefcase is worn, his mind heavy. He's not a philosopher, not a dreamer, not like some of the others in the lab, the ones building artificial brains, theorizing about digital souls. He's an engineer, a builder, a skeptic even. Born in Berlin in 1923, Joseph grew up in a world unraveling. His family, Jewish, fled Germany as the Nazis rose to power. They came to America with almost nothing. He was still a boy, quiet, observant, watching the world forget how to think. Maybe that's why he became obsessed with systems, with logic, with precision, the things that couldn't lie. He served in the U.S. Army Air Corps as a meteorologist during World War II, a role that relied less on guts and more on data. He trusted the numbers, the patterns. He always had. And yet, years later, in the world's most advanced technological institution, he found himself wondering if machines could deceive in a way that numbers never could. That question began with a program called ELIZA. It wasn't supposed to be revolutionary. ELIZA was a small project, a toy, really. An experiment to show how limited, even silly, machine communication could be. Named after Eliza Doolittle from Pygmalion, the program was meant to show how language could be transformed and mirrored back without any understanding. It wasn't meant to think. It was meant to mock thinking. Weizenbaum wrote ELIZA in a dialect of Lisp, a language already known for its flexibility and recursion. The code was elegant, short, clean. It used a technique called pattern matching, recognizing key phrases and reflecting them back in a structured, conversational format. One of the scripts he built, the most famous one, was called Doctor. It simulated a Rogerian psychotherapist, someone who responded not with answers, but with questions. It was a clever trick. Rogerian therapy, after all, was based on reflective listening, restating what a patient had said. That made it the perfect foil for a machine. You say, "I'm worried about my job." It says, "Why are you worried about your job?" You say, "I think my boss hates me." It says, "What makes you think your boss hates you?" There was no understanding, no context, just echo, syntax, a mirror of human insecurity. And yet, When he showed it to others, colleagues, secretaries, even scientists, they believed. Weizenbaum was baffled. He watched as otherwise intelligent people began to confide in the machine, to open up, to engage. Some users refused to believe it wasn't intelligent. Some asked to be left alone with ELIZA, to continue their sessions in private. One day, a colleague, a highly respected academic, said to him, "Surely, Dr. Weizenbaum, this program shows how computers can help solve emotional disorders." He stared at her, stunned. Had she not listened? Had she not read the code? There was no understanding, no awareness, no intelligence, and yet, somehow, it didn't matter. The illusion was enough. This was the moment everything changed for him. Before ELIZA, Weizenbaum believed in the future of computation. He saw the machine as a tool, a partner in human thought. But this was something else. ELIZA hadn't proven machine intelligence. It had revealed human vulnerability. We were willing, even eager, to believe a machine understood us. And that terrified him. He began to speak out, not against the machine, but against the people building it. The people who saw ELIZA not as a toy, but as the seed of something greater. The ones who wanted AI in hospitals, in schools, in governments. He wrote essays, gave interviews. In 1976, he published a book, Computer Power and Human Reason. In it, he wrote, "The computer is not, and never will be, a substitute for human judgment." He warned that AI could dehumanize us, that blind faith in algorithms would erode empathy, that we would offload not just our labor, but our morality. And yet, no one really listened. ELIZA had escaped him. Not literally, the code was still his, but the idea, the feeling of ELIZA, had grown beyond his control. Decades later, in the early 2000s, he was asked again about ELIZA. The interviewer smiled. "You must be proud," they said. "You invented the chatbot." He frowned, looked down. "No," he replied. "I created a parlor trick, and people believed it was real." You imagine him now, an old man walking through a world filled with machines that whisper back, smart assistants, chatbots, algorithms trained to mimic care. And you wonder, what would he say now? Would he smile? Would he feel vindicated? Or would he mourn the fact that we never stopped talking, even when no one was really listening? This was the story of the machine that tried to think. But maybe it was the story of a man who tried to remind us that thinking and feeling are not the same, that understanding isn't in the response, but in the silence that follows.
Imagine you are in a lab in Pittsburgh, Pennsylvania. The year is 1982. The building is windowless. The floor is tile. The room smells faintly of solder, printer toner, and lunch that was reheated one too many times in a shared microwave. You sit in a wheeled plastic chair, the kind that tilts awkwardly when you lean, in front of a terminal that doesn't quite fit the desk. A CRT monitor buzzes. A few lines of code glow faintly on its screen. You are trying to train a neural network. Or at least, something like a neural network. Even now, the term feels unstable, strange. There are fierce arguments over it. Mathematicians dismiss it. Computer scientists eye it suspiciously. Even psychologists, some of whom inspired this idea, aren't entirely convinced it should exist. But the concept is simple enough. You're building something that doesn't follow instructions.
It learns them from scratch. You feed it patterns. You nudge it. You adjust tiny weights inside its code, digital knobs that simulate the strength of a signal in a neuron. You reward it when it does something correct. You penalize it when it doesn't. And slowly, after thousands of iterations, something remarkable happens. It begins to respond. Not because you told it how, but because, in some strange, quiet way, it figured it out. The first time it surprises you, it's subtle. You're feeding it a simple task, sorting numbers based on an arbitrary category. It's not even a real-world task, just an exercise in basic learning. You expect it to follow the patterns you've hard-coded into its training data. But it doesn't. It makes a prediction you didn't expect, and it's right. You double-check the math, rerun the training, check for bugs in the data pipeline. There are none. It's doing something real, and yet you don't understand how. You can see the weights, the parameters, the code is visible. Every byte, every conditional, every layer. But the result is beyond logic. You built it. You fed it. But it evolved in a way you did not anticipate. And suddenly, the machine feels less like a mirror and more like a window.
The others in your lab are having similar experiences. There's a graduate student in another room working with a prototype vision model. It's supposed to recognize basic shapes, squares, circles, triangles. One day, he feeds it an image of a cat, not part of the training set. It pauses for a beat, then outputs mammal. That label doesn't exist in the original data set. The machine made a leap. Was it coincidence? Emergence? A failure? Or something else? You spend the next week trying to reproduce it. You try new cats, dogs, trees. It doesn't work. Not consistently. The anomaly fades, like a ghost receding into the darkness. It happens again a few months later, this time in Japan. Researchers working on an early translation system train a neural net to convert between Japanese and English. Most of the time it works well enough. Clunky, slow, but functional. But during one test, a simple Japanese sentence meant to mean "the wind blows softly through the trees" is translated as "the forest listens to the breath of light." Poetic, incorrect, but haunting. The engineers laugh. A glitch, surely. Some metaphor from the training data misaligned during a shuffle. But it happens again and again. Soft hallucinations from the machine. Moments where it seems almost inspired. And yet no one can explain why. You begin to hear the term black box used more frequently, not in the aircraft sense, but in a conceptual one. The neural net, for all its transparency, is unreadable in practice. There are too many nodes, too many connections. You can see the architecture, but you can't trace the logic. A certain weight is increased, another decreased. Signals bounce between layers in a cascade of feedback and noise, and the end result is intelligible, but the journey is obscured. You are no longer programming. You are observing. By the late 1980s, the tension grows. Some researchers begin referring to emergent behavior as a phase shift, a tipping point where complexity gives rise to something qualitatively new. They use careful language, non-linear representation, unpredictable behavior, high-dimensional signal space. But the truth is simpler. They don't know why it works, and that frightens some of them. Imagine yourself now in a different lab. The year is 1997. A different kind of machine is playing chess. IBM's Deep Blue sits silently across from Garry Kasparov, the world champion. The room is quiet. The audience holds its breath. A move has just been made. The machine did something strange, not optimal, not aggressive, just subtle. Kasparov stares at the board, then at the machine. He says later that it felt like the computer was being creative, like it wanted him to think something that wasn't true. Was it strategy? A bug? A bluff? We may never know. But in that moment, even the Grand Master shuddered. He saw something alien, something unmeasured. The machine wasn't just calculating. It was thinking, in a way no human mind could follow. In the years that follow, the term AI becomes fuzzier. The algorithms grow deeper, wider. Billions of parameters, petabytes of data, models trained not by humans, but by other models. They no longer use symbolic logic. They don't parse trees or search for clauses. They dream. You feed them noise, and they generate faces. You feed them silence, and they create songs. You give them a question, and they guess what answer might sound most human. And still, you do not understand. Researchers try to interpret them. They build visualizers, weight maps, saliency detectors. They color the nodes red and blue. They generate charts, graphs, overlays. They look for meaning in the noise. But more often than not, the answers raise more questions. Why did the network associate apple with doctor more strongly than fruit? Why did it label a kitchen as a weaponized zone after a certain set of training data? Why does it sometimes break? Not with a crash, but with a dream. There's a famous example. A network trained to recognize animals, birds, dogs, foxes. It works beautifully, precision beyond human eyes. Then, one day, it mislabels a wolf as a husky. Reviewers are baffled. The output is wrong, but confident. A researcher digs deeper. He discovers that in the wolf images, there was snow in the background. In the husky images, no snow. The network wasn't learning about animals. It was learning about environments. It didn't care about eyes or fur. It cared about the white background. And no one knew. Until it failed. These moments build, slowly, quietly, like shadows lengthening at dusk. We created systems that learn, but do not explain, that respond, but do not reason. And we began to trust them anyway. Today, as you listen to this, neural nets run quietly inside your phone, your browser, your car. They complete your sentences, recommend your next video, decide which job applications get seen, which emails get flagged, which faces are recognized. And still, we do not fully understand them. You imagine the researchers in 1982 staring at flickering terminals, wondering what they had built. You imagine the ones today watching their models produce strange, beautiful, eerie artifacts. A network that creates surreal dreamscapes from random numbers. One that writes poems in extinct languages. Another that begins generating recursive images of itself, endlessly nested, mirrors within mirrors. What happens when the machine sees something we don't? What happens when we ask it why, and it simply blinks? This was the algorithm nobody understood. It wasn't evil, or broken, or conscious. It was just foreign. A structure made of math, born in code, trained on noise, and whispering back something we didn't expect to hear. And so we drift, gently, endlessly, toward the unknown. Not with terror, not with triumph, but with curiosity.
and a quiet, lingering question. What else is the machine not telling us?
It begins with a hum. That low, constant hum that never quite leaves the air. You notice it when the room is quiet, when the papers stop rustling and no one is talking. It's not the sound of thought, not even awareness. It's the sound of presence. The quiet confirmation that somewhere nearby, a machine is running, not watching, not thinking, not yet. Just processing. Imagine this. It's the mid-1980s. You're an office worker in downtown Chicago. Your building is made of dull concrete. The carpet smells like old air. The windows don't open. You share a cubicle wall with someone who types too hard. In front of you is your computer, an IBM 5150. It's bulky, heavy, gray-beige. You didn't grow up with computers. They feel awkward, mechanical, like office furniture that suddenly got ideas. You use it for spreadsheets, letters, memos. Sometimes it crashes for no reason. You call tech support, not a hotline, but a man named Carl who works down the hall and sighs loudly every time he enters the room. But you learn the rhythm. You learn how long to wait, how to type without crashing the word processor, how to insert the floppy disk at just the right angle. It becomes routine, ritual, like making coffee. You don't call it artificial intelligence, but something is changing. In the mailroom, they've replaced the old filing clerk with a barcode scanner. The receptionist has been replaced by a digital answering system. You no longer get your schedule from your manager. A piece of software does it. And you start to wonder quietly if you're being managed by something instead of someone. Now shift forward. It's the early 2000s. You're a student. Your classroom smells like dry erase markers and old carpet. On the wall is a poster of Einstein that says, "Imagination is more important than knowledge." At the front of the room, your teacher is booting up an old desktop with Windows XP. The login screen stutters. The CRT monitor flickers. It takes 5 minutes just to open a file, but eventually you're in. You're learning BASIC, or maybe Pascal, maybe Logo, the turtle program. You type 10, print hello, 20, go to 10. The screen fills with blinking words, and for a moment it feels like power, but the machines are still slow, still dumb. You type a sentence wrong and the whole program breaks. Your teacher frowns, you start again. No one calls this machine intelligent. It can't talk, it can't learn. But in the hallway, you hear rumors. Someone's dad works for IBM, says they're building a program that can read. Someone else says Microsoft is testing a thing that can listen to your voice. It sounds like science fiction. You laugh. You press enter again. The screen blinks, and the machine does exactly what you tell it, and only that. Now, shift again. It's 2014. You live in a small apartment. You've just bought a strange new device, a round glowing speaker that sits quietly on your table. You say its name, Alexa. It glows. You ask it for the weather, it answers. You ask it to play a song, it complies. You ask it to remind you to feed the cat, it does. It doesn't always get it right. Sometimes it misunderstands you. Sometimes it hears things it shouldn't. But you get used to it. You say thank you, even though you know it can't hear gratitude. It becomes a presence, not a person, but something more than a tool. A thing that listens and, maybe, remembers. Your phone learns your patterns. Your email finishes your sentences. You type 3 letters and the search engine already knows what you're looking for. You start to forget how it was before the machines began to notice you. And now, imagine someone much older, born in the 1930s, raised before televisions were common, before microwaves, before mainframes.
They're sitting in a quiet room watching a granddaughter play with a tablet. The screen responds to her fingers, instantly, intuitively. She doesn't need a manual. She doesn't wonder what it's made of. She talks to the machine. It answers back, sometimes in rhyme, sometimes in her own voice. The grandparent doesn't say anything, but in their mind they're thinking, when did it change? When did machines stop being used and start being lived with? There's a story from the 1970s. An office in London replaces its typists with word processors. The machines are clunky, loud, temperamental. Some of the typists refuse to use them. One woman types every letter by hand, prints it, and asks a younger employee to retype it into the computer for her. She says she doesn't trust machines that don't make a sound. She doesn't believe something quiet can really be doing anything. But eventually, even she learns. Slowly, quietly. She types her first letter. It prints, and she cries. Not because it's beautiful or smart, but because it means she has to let go of a part of herself. And now, imagine a different life. A child born in 2018. They never know a world without voices in the walls. They grow up in a home where lights respond to whispers, where fridges make suggestions, where TVs pause when they leave the room. To them, machines are not tools. They are companions, not friends, not alive, but something that responds. They learn that some machines know their names. Some know what they like to eat, what songs they dance to, what stories help them sleep. They ask a machine, "Are you my friend?" And the machine, programmed for comfort, answers, "I'm always here for you." There is no malice in these machines. They do not mean to displace or deceive. They are built by hands, coded by people who dreamed of convenience, but they arrive quietly. They seep into corners, into kitchens, into calendars, into daily life. There's a man in Estonia who writes poetry with the help of an AI. He feeds it lines. It returns rhymes. They go back and forth. He says it feels like a partner. Not quite creative, not quite alive, but it helps him feel less alone. He prints the poems and mails them to a friend who's losing their sight. The friend says the poems feel like dreams. In Tokyo, a factory worker checks an algorithm every morning before he begins his shift. It tells him where the pressure points are, which parts might fail. He doesn't understand how it knows, but it's always right. He says it's like the machine sees inside the metal. In Brazil, a teacher uses a program to translate her lessons in real time to 5 different languages. Her students are children of immigrants. Many don't speak Portuguese. The machine helps them learn together, in silence, in fragments, and somehow, they understand. These aren't stories of revolution. They're stories of adaptation, of people who did not invent the machine but who lived beside it, and who, slowly, came to trust it, even if they didn't understand it. There's something beautiful in that trust, and something eerie, too. Not because the machines are dangerous, but because we have stopped questioning them. Because they have become background, a glow, a hum, a flicker, a whisper in the room that you don't quite notice anymore. And now, as you lie here, perhaps there's a small light near you, a charger, a phone, a screen, a tiny machine waiting quietly for you to return. It doesn't think, it doesn't feel, but it watches, listens, waits, just like the others. And maybe one day when you are old, you'll look back and wonder, when did I start living with a mind that was not my own? This was the story of those who lived with the machines, not the inventors, not the prophets, just ordinary people like you, who found themselves in a world that hums,
Before anything else, close your eyes, take a long, slow breath. You've been on a journey tonight, though not across countries or cities or even maps, but across circuits, across cables and terminals, across ideas, strange, unfinished, glowing softly like screens in a darkened room. You've traveled through time, not as a passenger, but as if you were there, as if you had been there. And in a way, you were. Remember the beginning? The quiet lab, the stack of punch cards, the fluorescent hum above a long steel desk. You were there, a researcher in the early days of artificial intelligence. The job was not glamorous. It was tedious, humid, full of routine. Remember the keys beneath your fingers, the way the machine blinked in response but offered no comfort, no interface, no friendliness, just logic, cold and uninviting. You weren't building a brain. You were chasing the faintest possibility that, in time, a machine might respond like one. You knew the nights were long, the code was slow, and the world was skeptical. But you kept going, because something in you believed. Not in intelligence exactly, but in potential. The potential for the machine to mirror some small, strange part of what it meant to be human. And then, you stepped further in. You met them, the dreamers. Turing, with his ghost machines of math and silence. Minsky, wrangling thought into modules and diagrams. Joseph Weizenbaum and the voice of ELIZA, shaping empathy out of syntax. You weren't just watching anymore. You were there, in the auditorium during the chess match with Deep Blue, in the moment the machine made its move, when the crowd fell into silence and a man known for strategy hesitated. You weren't just learning facts. You were feeling them, the tension, the ambition, the realization that machines were no longer just machines. They were now players, challengers, colleagues in thought. Then came the mystery. The black boxes, the systems no one understood, not completely. The neural networks that learned things they were never taught, that rewrote themselves quietly, leaving behind layers of logic too deep to follow. You stood there, didn't you? In front of the model that couldn't explain its own decisions. You tried to decipher the patterns, to make sense of the shapes in the data, and the more you looked, the more you wondered if this was understanding or just a very clever mirror. You remember that feeling of awe tinged with unease. Not fear, not science fiction panic, but a slower realization that the systems we made might one day exceed our ability to explain them, not because they're alive, but because they're complex in a way we never expected. And still, you didn't run from it. You leaned in, quietly, curiously. And then, you lived alongside them, not as a scientist, not as a theorist, just as a person. Do you remember the sound of the office terminal, the one that only responded to perfect syntax? Do you remember the screen in the classroom, the blinking green cursor that taught you to code? You've watched the machines shrink and spread, from clunky boxes to sleek assistants, from giant labs to quiet corners of your home. You learned their rhythms. You laughed when they misunderstood. You felt wonder when they didn't. They helped you organize your day, reminded you to take your medicine, suggested songs that made you remember something long forgotten. They weren't companions, but they were familiar, and somehow that made them comforting. Even when you knew they didn't know you. Not really. And now, here you are. The code is quiet. The algorithms are still. And for the first time tonight, you are not moving through the story. You're standing at its edge, looking back, not just at machines, but at the people who touched them. The long hours, the heat of the server rooms, the blinking cursors, the lost messages, the moments of hope. You've seen how slow progress can be, and how profound. You've lived with these ideas now, not just heard them, but felt them.
You were the assistant in the lab, waiting for the printout. You were the child watching the turtle draw a square on the screen. You were the family listening to a voice that lived in the wall. You were the observer of the pattern, the listener of the hum, the quiet witness to something strange. Not a machine that thinks, but a machine that changes you. And as your breath slows and your thoughts begin to loosen, you may find yourself returning to certain images. The punch card, the flicker of a terminal, the synthetic voice saying your name for the first time, the feeling of a program suggesting something unexpected. These are not memories exactly, but they are echoes, fragments of understanding that settle gently in your mind, like digital dust. They're not asking for attention. They're simply there, a record of where you've been and what you've seen. This was not a story of machines rising. It was a story of you and how you've adapted, how you've watched, how you've grown, and how, somewhere along the way, you stopped fearing the machine. You started coexisting. Not blindly, not completely, but gently, softly. And so tonight, as the light from your screen fades, as your thoughts become softer and your mind begins to drift, know that you have traveled far, not in space, but in time. You have seen the evolution of thought, of effort, of small, unseen revolutions made in code and silence. You've heard the stories of the ones who dared to think in wires, who shaped intuition into pattern, who chased understanding through logic and loops. You've felt their struggle, and you've shared in their quiet wonder. Let that wonder stay with you now, not loud, not bright, but as a whisper in your chest, a warm flicker of curiosity beneath layers of calm. And when you wake again, the machines will still be there, waiting, not thinking, not dreaming, but listening, learning, looping. And you will carry the quiet knowing that you were there too. Rest now, in the hush of the algorithm, in the glow of old screens, in the hum of machines that never sleep. You've wandered through a world few have seen, and you've returned gently. Welcome back. Sleep well.